we need to evaluate the value of the following. So let us begin. So here what we'll do, we'll start with the first term. So we have 2 raised to the power of log of 5 with the base of 3 minus 5 log of 2 with the base of 3. Now in the first term we have log of 5 with the base of 3 in the power or in the exponent form. What we'll do, we will use a property here. But if we have log of a at the base b, that's equivalent to log of a divided by log of b, and both of them are going to have a base of c provided the c is greater than 0. What we'll do, so we will rewrite our log of 5 with the base of 3 as log of 5 divided by log of 3. Now this time we'll consider the c to be equals to 2. Right. So that means we have log of 5 with the base of 2 divided by log of 3 with the base of 2. Now we'll take the denominator to the numerator. Here we will be using the fact that if we have log of a with base b, then this is the same as the reciprocal of log of b with the base of a. So here we can use the definition to find out this particular expression. So that means our expression will then become log of 5 with a base of 2, and this will be multiplied to the denominator. When it goes to the numerator, will be log of 2 with the base of 3. So this is log of 5 with the base of 3. So what we'll do, we'll replace this value in our first term. So our first term then becomes 2 raised to the power of log of 5 with the base 2 multiplied to log of 2 with the base 3, minus, we'll keep the second term intact. So 5 raised to the power of log of 2 with the base of 3. Now, whole reason we are doing this in this particular fashion is now what we can do, we'll use a fact of the indices. That means if we have a raised to the power of b times c, so this is the same as a raised to the power of b whole raised to the power of c. We'll use this fact to rewrite our first term as 2 raised to the power of log of 5 with the base of 2 whole raised to the power of log of 2 the base 3, minus the second term 5 raised to the power of log of 2 with the base 3. The reason why we have written in this fashion, because if we look at the base of the exponent, that's 2, and the base of the logarithm is also 2. So they are exactly the same. There's a property in logarithm. So if we have a raised to the power of log of b with the base of a, so the base of the exponent and the base of the logarithm, they are same. Then in that case, the expression simplifies to b. That means we can rewrite this expression as equivalent to 5. So we have 5 raised to the power of log of 2 with the base of 3. And the second term is negative 5 raised to the power of log of 2 with the base of 3. So that means they're exactly the same term and they will cancel each other to give us 0. This is the value of a given expression and its value is equals to 0.